All right. Today we're going to be taking a look at 1.2, which is talking about combining like terms and distribution. The first thing we want to kind of have an understanding of is two main vocabulary words. Um, Anytime I say constant, right? Constant, all constant means is a number by itself. Number by itself. Okay. So for example, a constant would be 4, 7, 50, right? All of those are numbers by themselves. Uh, and the next thing is a coefficient. Coefficient. Okay, a coefficient is the number in front of a variable. So, for example, if I had the term 5x, my coefficient is the 5. Okay, so if I'm talking about coefficient, I'm not talking about the whole entire term itself, just the number in front of the variable. All right. So let's take a look at distribution first because I believe that's going to be a little bit simpler. Okay, distribution uh, means we're going to multiply. Okay. Um, Distribution means we're going to multiply. We're going to take one thing and distribute it to everything else, right? Distribute as a word means to like pass out. Um, so I had someone explain this to me before as, you know, if you have candy and you're wanting to give some to all of your friends, right? You're going to want to distribute that to everybody. You're not going to want to jump over somebody else. So, plain and simple, in the simplest form, it will look something like this if you had a problem like this. Okay? Typically with distribution, right, you're going to have something inside of a parentheses and something outside of the parentheses. Although sometimes you can have two sets of parentheses, and that's fine. So in this case, I've got one constant term and one term with a variable. Now to distribute this, all I have to end up doing is taking 2 and multiplying it by 2x. So 2 times 2x would give me 4x. Okay. Say I had something a little bit more complicated. So maybe 4 times 3x plus 10. Okay. Now you've got a constant term out in front, but now I have two terms. You can tell it's two separate terms because it's going to be separated by an adding or subtracting. Um, it could also be separated by a division sign. Multiplication, we would multiply them together. But say if this was 3x divided by 4, that could also work. I'm going to take this constant term and multiply it by everything inside. So 4 times 3x and 4 times 10. This is where distribution can get confusing, and this is where you see the number one mistakes is people usually, if they do make a mistake, only apply this constant to the first number. It's got to apply to everything. It's like if you had a mailman going down the street, right? The mailman's going to hit every single house. He's not going to hit this house and then skip this house. So then we multiply that. So we do 4 times 3x, which will give me 12x. And then 4 times 10, which will give me 40. Now that's a separate term. And since this is positive and this is positive, positive 4 times positive 10 will give me positive 40. So I'm going to have plus 40. Okay. This can also apply whenever you have a variable out in front. So say I've got 7x times 2x minus 1. Okay. Now, this is a term by itself, so I've got to multiply this term times everything here. Okay, so I've got to take 7x times 2x and 7x times negative 1. Now, we have to be careful here, right? Since there's two parts of this term, I've got to multiply both things, right? So you do 7 times 2, which will give me 14. And then I've got to take x times x. So it's times itself. So anything times itself is squared. So x times x will actually give me x squared. So I end up with 14x squared. Do the same thing here. 7x times 1, but it's negative. So a positive times a negative is going to give me a negative number. So I'll end up with negative 7. Since there's no x to multiply it by here, I'm just going to leave the x alone. I'm just going to leave it as just a singular x. Okay. And when we get to combining like terms here in a little bit, I'll explain why I wrote these separate and I didn't combine them together. All right. You can also do the same thing if you have a negative number. So say I have negative 5x times negative 2x plus 3. Okay, so negative 5x times negative 2x plus 3. So I'm going to distribute this to everything inside, right? 1 and 2. Negative times a negative is going to give me a positive. So it'll give me positive 10. And then x times x is going to give me x squared. Okay. Negative 5 times positive 3 will give me negative 15. Since there's no x to multiply here, I'm just going to leave it as a singular x. Now this can also apply to much longer problems. So say I've got 3 times x squared plus 2x minus 4. Okay, so now I've got 3 terms, and the process remains exactly the same. I'm just going to apply this to everything inside. And I like to draw the arrows so that I know, okay, I know I'm multiplying this times this. Now I'm multiplying this times this, and this times this. Okay, so 3 times x squared, it's going to leave me with 3x squared. Okay, and 3 times 2x is going to give me 6x, positive 6x. And 3 times negative 4 will give me negative 12. Okay, another way you can look at this, even if you're dealing with a bigger problem, it applies the same way. So say you have 2 binomials. Okay, so let's go 2x plus 4 and 3x minus 2. Okay, now I can still distribute this. I've just got to do it one at a time. So I'll take this 2x and multiply it by everything here. Okay, then once I do that, I'll take this 4 and multiply it by everything here. You might also know this as FOIL. You've been taught in the past because you take your first numbers, your outside numbers, your inside numbers, and your last, which if you spell that out becomes FOIL. Okay, so this 2x times 3x will become 6x squared. This 2x times negative 2 will become negative 4x. 4 times 3 will become 12x. And 4 times negative 2 will become negative 8. Okay. Right now, I'm going to leave this as this, and I'll explain why this isn't your final answer right now. So when we're doing distribution, we'll have some situations like this problem here. Okay. And to finish this problem off, what I have to do is combine my like terms. Now, to combine my like terms, right? Combining like terms. Okay, combining like terms just means finding the things that have the same variable with the same exponent. And we're going to combine them. Now, combining doesn't always mean that it's going to be positive, right? And I'll show some examples here in a second. So, let's say we had just solved that problem, right? And I had, I think it was 6x squared minus 4x plus 12x. I think it was plus 8. Okay, if I'm looking at this problem, I'm not quite done because I can't combine my like terms. Okay, so like we said, my like terms was things that have the same variable and the same exponent. So even though I've got 6x squared, 4x, and 12x, even though they all have x's, this one has an exponent of 2, and these don't have an exponent at all, or an exponent of 1. So I can't combine these with this. But I can combine negative 4x with positive 12x. Now, a way that you can do this, and I've seen people do this in lots of different ways. You can either color code it, right? I can know, okay, this will be green. All my x squareds will be green, and I'll underline those. All of my x's will be, like, say, purple. Okay, so I know this is an x, and I know this is an x. And then all of my constant terms, I don't know, say will be this lighter blue. Okay. I've also seen people do different shapes, right? So I might square all of my x squareds. Okay. I might put a triangle around all of my x's. Okay. And then maybe I circle all of my constant terms. It's really up to you how you're going to do this. I don't think there's any teacher that's going to force you to do it one way, and definitely when you get to standardized testing, they're not going to do this. But this helps me organize my thoughts a little bit better and say, okay, this goes with this. How can I combine those? So in this case, I have no other x squareds, so I'm simply going to drop that down and leave it alone. So my final x squareds will be 6x squared. Now I've got negative 4x and positive 12x. When I combine those two, right, I'm essentially taking positive 12 and subtracting 4, which will give me 8. Okay, and then here I would drop this straight down, and that would become plus 8. Now, when we get later into factoring, we would have more to do here, but for the sake of today's lesson, this would be as combined as the like terms are going to get. Okay, you can also see this with multiple variables. So like, say I have a problem that says like 2a plus 4b minus 7a plus, I don't know, 10b. Okay, if I want to combine these like terms, right, they have to have the same variable and the same exponent. Now, if I look here, I've got 2a's and I have 2b's. So I can do those separately, right? If I'm just looking at the a's, I'm going to simply ignore the b's, right? So you've got 2a minus 7a. 2a minus 7a will give me negative 5a. Okay, and then if I'm looking at b's, I'm going to ignore the a's. So you've got 4b plus 10b will give you 14b. So that would be fully combined, my fully combined answer there. Now, it is important how we combine some of our like terms. we want to go in descending order. So when I'm talking about descending order, I'm really talking about the exponent. So you write it in a way that the exponents go from greatest to least. Now the least is just another way to say your constant term. Your constant term will always come last. Okay, so for example, if I had a problem that was like x squared plus 5x to the third plus 4x plus 2x to the 10th plus 17 plus, that kind of looks like an x, so plus, I don't know, just x to the 6th. Okay, so say it was this problem and they wanted you to rewrite it into descending order. I'm looking at the exponents itself, not the coefficients. Number one mistakes I see there is people look at the coefficients. I don't care about the coefficients. I just care about the exponents. So in this case, I see this has my highest power at 10. So I know that is going to be what comes first. Okay. And if it helps you to, I like to cross things out as I'm combining them. Okay. Then I look at the next highest. Okay, I've got a 2, a 3. There's nothing there, so it's a 1. Constant, I know it's always going to come last, and then I have x to the 6th. So I'm going to do plus x to the 6th. Okay, that's gone. My next highest exponent would be 5x to the third. Okay, that's gone. And my next highest exponent would be x squared, so plus x squared. Next highest out of those two is 4x. And then last but not least, I would have a 17. So this would be written in descending order because it goes from your greatest exponent to your least. Okay, and you'll run into this a lot when we're looking at this kind of unit where we're talking about combining the like terms. They'll be all jumbled up. We want them to go in descending order. Now, when it comes to variables, there's some teachers that will tell you it's important to go in alphabetical, but I don't think that's something that we're going to count off for, right? So if you had written 14b minus 5a, like in this situation, that's not that big of a deal, okay? You also might run into a problem that has both things, right? So you might have to combine like terms and distribute. So maybe I have a problem that's like 2x squared minus 4x plus 5 times x plus 10. Okay, when I'm looking at this problem, we got to follow PEMDAS, right? So there's nothing I can do here, but I need to take care of this here, your distribution, first. Okay, so no matter what, I want to take care of this distribution first. I've got to do 5 times x and then 5 times 10, right? So 5 times x will give me 5x. 5 times 10 will give me 50. So now, since I didn't do anything to these, I'm just going to drop them straight down. Okay, so then from here, I can combine like terms. There's no other x squared, so that's going to stay as 2x squared. Okay, I have negative 4x plus 5x, which will give me positive 1x. If your coefficient is 1, you don't have to put it. You can just leave it as a variable. And then there's no other constants, so that would be my answer there. If I was looking at this as a basic like solving equation, everything still works exactly the same. So for example, let's go with like 3x plus let's go 6 equals, I don't know, 2x plus 10. Okay, that should give us a nice clean answer. I'm going to take care of distribution on both sides first. Okay, so 3x, 3 times x will give me 3x. 3 times 6 will give me 18. Here I've got 2 times x, which will give me 2x, and 2 times 10, which will give me 20. Okay. Now, I want to combine like terms. My only problem is they're on separate sides. When you're dealing with an equation, I can't just combine like terms straight across this equal sign. Okay. The way that we combine like terms when they're on opposite sides is by doing the opposite of the operation. So if I know I want to combine these x's, right, I might want to cover up everything else. Okay. And so since they're on the opposite side of the equation, I need to do the opposite of what this is. And since this is positive 2x, I'm going to subtract 2x from this side. Okay, so 3x minus 2x will just leave me with 1x plus 18. Now over here, this is going to cancel out. I'm just going to be left with 20. Now to solve this, I want to get this x by itself, so I need to take care of this plus 18. I'll take care of the plus 18 by subtracting 18 from both sides. And that will leave me with a nice clean answer of 2. Like terms. These are two of the main concepts that we'll use throughout the school year. So it doesn't matter if we're looking at maybe linear functions or quadratic functions. These two things will always be used. So it's important to have a basic understanding of this. And we talked about a few different strategies that you can use to help us remember those. All right.